Now we're going to focus down on chapter 8 of my new book. And this is going to be the last chapter in this book, and it's entitled From Kathmandu to the Big Apple. It's probably one of the funnest or most interesting chapters of all. So as time went on, and we were really, we were in the weeds lost in the forest for the trees of trying to identify new genes of cell cycles, cell growth and cell proliferation and that sort of thing. And at the same time, we were, doing also these immunological experiments. And so I realized that the molecular biology stuff was really labor intensive. And it took much longer to come to a project to come to fruition. When we were doing primarily just cell culture work, we could knock it off in, a few weeks. This was taking months and years and so forth down the line. So I surmised that I needed to change my whole modus operandi, which meant that I had kept my team as small as I thought I could get by with. And it was never more than 6 or 7 or 8 people in the lab at any one particular point in time, which made it easier for me to manage all the people and supervise things and make sure I knew exactly what was going on. One of the dangers is you get so far removed, you're in the office writing papers and grants and all this stuff, you can lose your touch in terms of the daily nitty-gritty of the experiments and so forth, exactly what's going on, which experiments are working, which experiments are not working, and why, and all this other stuff. Who's behaving properly on the team, and who's misbehaving on the team. So I figured that in order to move along more rapidly, I was going to have to change my MO, and I was going to have to get a bigger team, which meant that I was going to have to sort of expand the projects that we were working on, as well as the members of the team and their expertise and so forth. So I was thinking about, at the end of the 80s, about these kinds of thoughts and so forth. And things happen in your life where you least suspect them or you can't anticipate them. I had this fantastic study in our house in Hanover, New Hampshire. I can't remember how much I told you before, but we were on a one-way street that bordered a nature preserve that fell off into a ravine that went down into a brook that then drained into the Connecticut River as a tributary. And way down further south was one of those lone mountains in Vermont, whose name was Mount Ascutney. And it was just, a single peak way off in the distance. It was really great view. And in the fall time, when the leaves were out and so forth, it was just magnificent. Well, just off of that, our veranda where I would look out on this vista, I had a little study. I think I mentioned before that the house was owned for several decades by a botany professor at Dartmouth, and it had to have been his study. It was lined in cedar. And it had its own fireplace, and it was a small, sort of like, well, maybe 2 or 3 twice the size of a closet, and but it was wonderful. I could get in there and shut the door, and the kids could go, raise hell wherever they were raising hell. And I had this little sanctuary. One night after dinner, I was sitting down in front of my fireplace. In fact, this is where I did all my writing. And at least in the winter months, in the summer months, I actually wrote outside. We had a nice little garden and so forth. So I was in my study, and I had started a fire, and I was leafing through the Journal of Experimental Medicine, which was and is really an immunological journal, even though it's called the Experimental Medicine. And I came across an article that really caught my eye because it was about IL-2, interleukin-2. But in addition, this group had used interleukin-2 as injecting it into the skin of leprosy patients. And they said in this article, as I went through the whole thing, that the IL-2 had the effect of generating an increased number of cytotoxic CD4 positive T cells in these people and in these patients. And of course, the phenotype of a helper T cell is supposed to be CD4. That's the molecular marker, whereas the cytotoxic or killer T cells, the molecular marker is CD8. So that was a little bit strange, but as you may recall, I may have mentioned back in some of the earlier chapters, when Ellis Reinhardt first made his T cell clones, he made both CD4 positive T cell clones and CD8 positive T cell clones, and both of them were cytotoxic. So this whole thing that separated this thing so nice and neatly and tied it up like a bow was really not true. But of course, you know, scientists are human beings, and human beings like to have everything really tidy. So they kept talking about the helper T cells and the killer T cells. And leprosy is an interesting, leprosy, you know, we don't really know a whole lot about it today because we don't have it, and it's not around very much. And leprosy is due to a bacteria. It's a rod, so they call it a bacillus, that infects the skin. And it just sort of grows underneath the skin and so forth. And in the process of doing that, it can destroy the nerve endings particularly the sensory nerve endings in your skin, particularly in your appendages, your nose, your fingers and your nose and your ears and all that stuff. And so I thought that was intriguing. And I knew the principal, or the leader of the lab. His name was Zan Cohen, and he was a well-established member of the immunological community from the Rockefeller University, which is down in New York City. And I forgot to say that one of the things in my office was I had this fantastic handmade desk that my father had made. And when I was around 4 or 5 or 6 years old, my father and my older brother and I went off into my grandfather's farm, which is in northeastern Ohio. And there was a huge cherry tree, must have been this big around the trunk. And we chopped that cherry tree down, and it sat there in the woods for like a couple of years. And then finally my father got the whole thing hauled off to the sawmill, and they sawed it into planks. Then it had to age some more in a very dry kiln kind of situation, and then he planed it down so that it was nice and smooth and whatever. And then because his hobby was woodworking, and he made this desk out of it for me. So I had this cherry desk and the cedar lining in the study and the fireplace. And so it was really nice. I really enjoyed it. And so back to Zan Cohen, I decided, I knew him, but I didn't know him really personally. I just knew of him. But I fired off a letter to him, and I said, "Dear Zan, I thought your new paper that came out in the JAM was really first rate." And then I signed my name. That was it. Of course, this is back before the email days, you have to remember. And almost in the return post, I got a reply back from Zan, and he said, "Thanks. We think so too." And that's all he said, and I didn't say anything else. And so I said to myself, well, I have to find out more about what's going on down there and what these guys are really doing, because this is very interesting. And so I wrote him another letter, and in the second letter, I said how interested I was in their findings and so forth, and I sort of invited myself down to visit him and find out, more and more about what was happening. And so the Rockefeller University was started in 1901 by John D. Rockefeller, because one of the family members, a niece, I think, of John D., came down with a severe streptococcal infection, a scarlet fever kind of thing, and died right around the turn of the century. And so he decided that one of the things he could do with his fortune, this is back before of Standard Oil and so forth. This is back before income taxes. I mean, he had more money than God. And so he decided to start an institute, which he did, and it was called the Rockefeller Institute. And they started it in New York City, and it was because this was the heyday of bacteriology. And this, prior to the Rockefeller Institute, was the Robert Koch Institute, which was established in Berlin 10 years earlier in 1891. And then the Pasteur Institute in Paris was established in 1895. So this was the third institute, and it was all focused down on the new hot thing in science at the time, which was all these new bugs and the bacteria and so forth. And around 1920 or so, I think, or maybe in 1930, they decided to make it a university. So they changed the name from the Rockefeller Institute to the Rockefeller University. Zan said, sure, why don't you come down? And I came down in the summer of 1989. And it turns out that Zan had he had a pretty big lab, I don't know, half a dozen or more junior investigators, and then they had postdocs and technicians and so forth. And he had a big operation going on there to study what he called host-parasite interactions and so forth. And he was interested in cell-mediated immunity, cellular immunity to different kinds of bugs. And he had by this time, by the end of the 80s, enough new cytokines, lymphokines had been discovered, identified, purified, cDNAs were cloned, and you could get your hands on large enough quantities to start to do clinical experiments in humans with pure cytokines. And he had already started with interferon gamma because that interferon gamma was, one of its original names was macrophage activating factor, MAF. And his whole expertise was focused down on the so-called phagocytic cells. Those are the cells that engulf foreign matter and debris and so forth and gobble it all up, digest it and rid the body of any foreign material that might get in. And there's several different kinds of phagocytic cells, but two major ones. In the blood, there are monocytes, which look like a lymphocyte, except they're about twice as big. And then in the tissues, there are macrophages. And macrophage means big eater, and I think I've talked about that before. Monocytes come out of the bone marrow, are produced in the bone marrow, and then they circulate around in the blood. And when they get into the tissues, they differentiate into macrophages. And he was an expert on macrophages. And the other kind of phagocytic cell that circulates in the blood is called the polymorphonuclear leukocyte, or a PMN. Metchnikoff, who first described them back in the 19th century, called them microphages, because they also engulfed stuff, and he could see that happening under the microscope, but they were smaller than the macrophages, the big eaters. These were small eaters. And so Zan he had different people in his lab investigating different aspects of all of this whole thing. And so he didn't ask me to give a seminar, which I thought was a little strange. I would have asked me to give a seminar, but anyway, he didn't. But rather he had me go around and just meet with all the different people in his lab to tell me what they were doing and how they were doing it and so forth and so on. And then and it turns out that he had decided to study leprosy because the bacillus, the leprosy bacterial rod, is in the same family as tuberculosis. And tuberculosis and he was studying tuberculosis as well. But tuberculosis was well known to be combated in the body, primarily a lot by the monocytes and macrophages. So the thing is that tuberculosis is difficult to study because it's in the lungs. And so in order to get at it, you have to start sticking needles into people's lungs and so forth. And it's a little bit dangerous as well as difficult. So leprosy was a good disease to study because it was right there in the skin. So all you needed to do is do a little punch biopsy, and you get a sample of skin, and then you could look at it under the microscope, and you could try to culture the blood bugs out of the skin and so forth. And so that's why he was studying this whole thing. And so at the end of the day, I had a nice chat with all the different people in the lab and learned what they were doing and so forth. At the end of the day, it turns out that one of the postdocs they were throwing a going away party for the person. And Rockefeller had a great faculty club down at in the ground floor of one of the buildings on the Rockefeller campus, which was the faculty club was really more for the students than it was or used by the students more than the faculty, because they had a bar and they had pool tables and ping pong tables and all this stuff. And then, lounge chairs situated all around so you could go down there and chat with, if you had a visitor and that stuff. It was very nice. So we went down to the bar and had drinks for a while and so forth, all the members of the lab. And then we walked up the street, up First Avenue, about 20 blocks. Or no, it was 10 blocks. Wasn't that far. Anyway, we walked at a very fast clip. We got to this Italian restaurant and had dinner, and we were all talking and around the table and so forth. And there was a lull in the conversation. And so Zan suddenly said, well, Kendall, why don't you come and go on sabbatical and take a sabbatical leave and come down here and spend some time with us? Well, I was taken aback. I was shocked, because it was just awkward, So I can't remember exactly what I said, but I said something to the effect that that was a very generous offer and I would think about it or something of that sort. And so I went back to Hanover. And I don't know, time went by. Maybe a month later, I thought about doing a sabbatical, but not seriously. About a month later, I got a phone call from Zan, and he said, we're going on a field trip to Nepal, to Kathmandu, Nepal, and we wanted to see if you wanted to come along with us. And we've only given humans one shot of IL-2, but now we've gone through those preliminary experiments and we know that it doesn't cause any toxicity. And so we thought we'd go to Nepal because they have a leprosy hospital over there. The problem with leprosy, as compared to tuberculosis, there's a lot of tuberculosis around, particularly in big cities in the United States, but there wasn't much leprosy. There was leprosy in the Philippines, and in Brazil, and in Nepal. And he had been over there a couple of years previously and checked out the place and decided that this was a good place that they could continue to do more experiments. The thing is, they'd already given one dose of IL-2 to patients, and they knew that if you injected IL-2 into the skin, it would cause a typical delayed type hypersensitivity reaction. And it's called delayed because it's not immediate. So, which is one of the reasons. It's delayed a day or two, okay? Immediate hypersensitivity is the classic allergy reaction. So that if you have, and that's what the dermatologist does when he gives you skin tests on your back or your arms or whatever, injects a little bit of an antigen into the skin. And if you have an allergy, the immediate hypersensitivity reaction is is well known now to be due to an antibody. That is, if you have a circulating antibody to a particular, like ragweed pollen, for if you have hay fever. And what that antibody does is it binds onto macrophages or also other cells, mast cells. If you then add the antigen, it binds to the antibody that's already on the surface of the macrophages in the mast cell, and it triggers them. And they release all kinds of goodies that cause this wheel and flare reaction. And that happens within minutes of the injection of the antigen. So that's an immediate, which they call a hypersensitive situation. Well, the delayed type hypersensitivity takes a day or two to develop. But in the end, you get a very similar kind of an appearance of what happens in the skin. The skin gets the classic signs of inflammation. It becomes red, becomes warm, it becomes swollen, and it's painful, it's sore. And those are the four classic signs and symptoms of inflammation. And at the time, so, and that's that whole thing, the delayed type hypersensitivity reaction to the injection of an antigen, of a microbe or whatever, anything foreign into the skin, it would take a day or two, and then you'd get this inflammatory reaction in the skin. And nobody really understood what was happening, what was going on in that whole reaction. But it was a test. You could test people for this reaction, and in essence, that became the diagnostic test for tuberculosis. And so there was a tuberculosis antigen reagent that the doctors inject into the skin, and they have you come back a day or two later, and they'd look to see if you have a positive reaction. And if you did, that means that you've been infected, and you've had an immune response to TB. It doesn't necessarily mean you're still infected. You could have cleared the infection and left behind. The immune system now has been armed, and it knows that you've been in bad territory. But nobody knew the essence, knew how this was all happening. But what they did know, there was another Rockefeller investigator from back in the 40s who did experiments with guinea pigs, and his name was Merrill Chase. And he showed that for the immediate hypersensitivity, you could transfer that from one guinea pig to another by transferring the plasma from the sensitized guinea pig to a non-sensitized, and then you could challenge them with the antigen, and now that second guinea pig would have an immediate reaction. But you couldn't transfer delayed type hypersensitivity with plasma that would contain the antibodies. But you could, if you took the spleen cells or the lymph node cells or the circulating lymphocytes from the blood and transferred that from one guinea pig to another guinea pig, you could get the delayed hypersensitivity reaction. So this became the sine qua non for cell-mediated immunity. And this was way before they ever discovered T cells and B cells and so forth. It didn't happen until the 70s. So that was all that was known at the time. And so I was very intrigued by the fact that IL-2 would cause a delayed hypersensitivity reaction, because that told me that it's not due to the antigen. The reaction is really due to the immune response, and it's due to the production of cytokines. And in particular, if IL-2 did it, that meant that IL-2 was really important for cell-mediated immunity. That was the way you diagnose cell-mediated immunity. So I was thinking, so what happened is that after I had come back to Dartmouth and was thinking about all these things and so forth, as I said, Zan called me up and he said, we're going to go to Nepal. This was sort of like August or something like that. We're going to go in November, and do you want to come along? So, we had reached in the lab, we had reached sort of an asymptote of our science, and it was, everything was really well taken care of. Carol Beadling was working on on cytokine response genes, and Nina Zhemoidzinos was working with Harmy Mayman down in Boston on the RAF kinase, and Stefan Ehlers was working on a project that had to do with immunologic memory. And everybody was fine. They didn't need me around on a minute by minute basis. So I decided, I said, what the heck, what the hell? I think I'll go down there. I'll go with these guys to Nepal. So it was very memorable, the whole trip. It took 2 or 3 weeks, 3 weeks or so. We were in Nepal for 2 weeks. We left the United States from New York City on the first Sunday of November, which is the day that they hold the New York Marathon. So I had flown down to New York the night before, and I stayed in a hotel overnight, and then and the city was up for grabs. I mean, it was really, I don't know if you've ever been there, the New York Marathon, but people come from all over the world, these runners, and they're out there running around and checking out the city and so forth, and it's really sort of a carnival atmosphere. It's really fun. And so that's just sort of added to the excitement that I was going on this long trip to Nepal, which is more than halfway around the world. So we left on Sunday, and we took a nonstop flight to Tokyo from New York City, west. And then we flew from Tokyo to Hong Kong, and we stayed overnight in Hong Kong. And everybody was sort of completely bonkers, jet lagged at this stage of the game. Anyway, we stopped overnight, and then the next morning we took a flight from Hong Kong to Bangkok, and then from Bangkok to Kathmandu. So we arrived at Kathmandu, and Kathmandu is a city. It's the capital of Nepal, and Nepal was then, I think still is a kingdom. And we were met at the airport by an Australian physician by the name of Warwick Britton. And he was driving a Land Rover, a great big Land Rover, and we all piled into the Land Rover and all of our baggage, luggage, and everything else. And he then drove us through Kathmandu and into the boondocks. And ultimately, they got to be just a dirt road with ruts all over the place. And it was, I thought to myself, I'm really going to the ends of the earth. While we were driving through sort of the suburbs of Kathmandu, there was I'll never forget this. There was a pond that was obviously fetid, where it was overgrown with algae, it was green and whatever else. And there was a water buffalo that was sort of bathing in the pond. And right next to the water buffalo was this woman who was washing the hair of like a 2 or 3 year old kid. And as we sped by in our Land Rover, I looked at that and I said to myself, well, now it came to me like a flash. And I said to myself, well, this is why the immune system, this is the result of how people had lived, for centuries, before they really discovered bugs and that sort of thing, and realized and knew that there's a whole microbial world out there that was infecting people. They were having epidemics and so forth, and people were dying right and left, just like Rockefeller's niece, scarlet fever and so forth. So that was a tremendous evolutionary pressure on human beings and all animals, everybody essentially. So that was really selected out for really efficient, functioning immune systems. That was sort of the raison d'etre for why our immune systems were so wonderful. So I just throw that in as a little example of, you can get really lost in the ivory tower, lost in your test tubes and so forth, and you don't realize what you're really doing. So we got to the hospital, which is on one of the foothills of the Himalayas, about 15, 20 miles outside of Kathmandu, and the hospital was on the other side of the hill, so we couldn't see Kathmandu from our situation. And they explained to me that the reason that it was on the other side of the mountain or the hill was because nobody in Kathmandu could see it then, and they didn't want to have to be. They didn't want to have to remember that there were leprosy patients and people that had leprosy at the time. The hospital had been started in the 1950s by some Christian missionaries and so forth, and it had been well established then by that time. We got situated in the late afternoon and had dinner and went to bed, and I got up the next morning and before sunrise, and I climbed up to the top of the hill of this crazy place, and way off into the distance I could see the Himalayas, big white peaks and so forth and so on. It was really surreal. I never thought I would ever be in Nepal, you know. We started in on our experiments, and the Rockefeller team, it was clear that Zan was the patron of this group. He was 63 years old at that stage, and he was really a very sort of soft-spoken, gentlemanly, professorial type. And he was well established as being one of the stars in immunology at that stage of the game. And then the principal investigator of this particular project in his lab was a person by the name of Gila Kaplan, who was a young woman who was an Israeli, and she was working on the leprosy experiments. And she had two postdocs with him. One person from the US was Jerry Hancock, and then another fellow from the UK, Anthony Malloy. And so this was the team, just me. And I had volunteered to, as they gave these patients the IL-2, I would take blood from the patients and purify out the white blood cells and stain them with antibodies that were fluorescinated antibodies. And then I could then fix them and then take them back to the States and analyze them in a flow cytometer back at Dartmouth. So the plan for the project had been well worked out by Gila and Zan. I mean, they crossed all the T's and dotted all the I's, and they knew exactly what was going to go on, when and what. And so the experiment was done such that they injected the patients twice a day, 12 hours apart. So they did it at 9 in the morning and then again at 9 at night. And they had set up periodic, blood draws from the patients that I then dealt with. They also did skin biopsies on these people because they wanted to look down the microscope to see what happened to the histopathology, what effect the IL-2 had on the structure of the cells and the skin and so forth. And they also had, through collaboration, set up situations so that they could, the bacteriologists who were experts in the leprosy bacillus would examine it from that standpoint. So November in Nepal is the first real month of the dry season. And it was sunny and warm, it was sort of like, maybe 60s at night and get up to mid 70s in the daytime. Very, very nice weather. And we never saw any rain the whole time we were there. We were there for 2 weeks. And so since we worked in the morning and then we worked in the evening and we had the afternoons off. I'm going to have to deal with Julia, my cat. Hold on one second. Yeah, I know you want to go out. So I knew that was going to happen. So we worked in the mornings and in the evenings, and we had the afternoons off. And so we took hikes all over the place. There were no roads, and we were in the foothills of the mountains, and the whole terrain was essentially rice paddies, cantilevered rice paddies all over the place. That was the major agricultural product of the whole thing, economic as well. And it turns out, so November was just past harvest season. They had harvested all of the rice previously to the time we got there, but they were then sifting through all the rice and so forth. And I got the impression that they separated out the work of this into genders, so that the men plowed the fields with oxen, and we saw some doing that, so forth. Whereas the women harvested the rice and then dealt with it afterwards and getting it ready, purified and so forth for market. And so in November, the men were off, there was the thing that was very characteristic was this sweet smell that was just permeated everything. And I finally realized that was from the rice wine that all the men were, they were drinking rice wine all the time and laying around in the pass, passed out and so forth. It was quite bizarre. Every now and then, so we would go off on these hikes, the whole crew and so forth, and just see what we could see on the other side of the mountain kind of thing. And every now and then we'd come on to a farmhouse, which were basically made out of mud walls with thatched roofs. And we were invited into some of these farmhouses. And so inside, they were quite small, and they had dirt floors, and the family lived in the hut, in the little farmhouse, together with whatever animals that they might have had. And so this is when I realized that this is why leprosy was endemic in Nepal, because essentially they were living amongst a huge milieu of microbes in these kinds of huts. Whereas in the Western world, we went through all that. And actually another place that was, that had a lot of leprosy was in Norway, up in the, north in the winter. They would hunker down into their houses and so forth. And they had a lot of leprosy there for the same reasons. I mean, it was unsanitary conditions essentially. But then the other thing I couldn't figure out was, and I think it's still not clearly figured out, was you'd see a family that was living in this hut, and one of them would have leprosy, but the other ones wouldn't. So why was that? And I'll leave that with you. I think it's due to some immunodeficiencies that are going on, and I wouldn't be surprised that there's a lot of incestuous inbreeding amongst the people in the population, which doesn't help that kind of thing. The infection with leprosy is interesting because there's two kinds of immunological reactions to the infection by leprosy. One is called a tuberculoid form, and that's because you see bumps underneath the skin, and macroscopically they are called tubercles, and microscopically, if you take a biopsy of them and look down in them, you have total round collections of macrophages and monocytes and macrophages. And inside of those macrophages, if you have the right stains, you can see the leprosy bacilli. So that was tuberculoid, and that was the good kind, because that meant that there was some sort of a host reaction that was walling off and containing the bacteria. The other kind, which is the kind that we were really studying, is called lepromatous leprosy. And they didn't form these walled off tubercles, so that you had disseminated throughout underneath the skin, just scads and scads of leprosy bacilli in the dermis, in the skin, underneath the skin. One of the things that happened while we were there in November of 1989, and the Berlin Wall came down on the 8th of November in 1989. And we heard about it on the shortwave BBC radio. And it was really surreal to hear about. I never thought we'd see this bastion of the communist bloc fall like it did. So back to the study and the results from the study, which we published subsequently when we came back from Nepal. Clinically speaking, we injected these people. It was such a nice day and so forth. Days that they had a rooftop on the top of the institute of the hospital, and we would take the patients up there and inject them with our IL-2 preparations, and we'd do it in the back. And they, over time, and we could see the delayed hypersensitivity reaction. And every time we did an injection, all of the previous injections would light up, and they would get bigger and bigger as the experiment went on. We did it for 8 days, And they developed what we call axillary lymphadenopathy. They have their lymph nodes underneath their armpit. You could feel it. And so, you know, we as clinicians, quasi-clinicians, we knew that this was a good thing because that meant that the immune system was responding. And the other thing is that when we injected the IL-2, it was an accelerated hypersensitivity reaction. It would peak within 24 hours, whereas if you injected an antigen, it would take 48 hours. And that was consistent with the idea that when you do the antigen, and it takes 2 days rather than 1 day, is it takes a day for all the cells, the T cells and so forth, to make the cytokines, and then another day for the cytokines to cause the reaction. We got skin biopsies that actually were taken by the physicians at the hospital 2 months later, and we saw, and they looked at the leprosy bacillus and so forth, and they found that there was a 5-fold reduction at distant sites, not just where we injected the IL-2, but you know, all over the body and so forth. And that if you treated the patients with, and that happened within 2 months of the IL-2 injections, if you treated the patients with antimicrobial therapy, they had 4 or 5 different drugs that they would put the patients on. It would take a year to see a 5-fold reduction in the number of leprosy bacilli in the skin. And then my experiments with the lymphocytes, what we found is that the B cells didn't change. They stayed exactly the same. The monocytes doubled and in the peripheral blood, and the T cells, both CD4 as well as CD8, went up within about a month or so, or within a short period of time, and then they essentially maintained it. And the most striking thing is the natural killer cells. The natural killer cells went up 6-fold, and that we didn't necessarily expect that, but that's what we found. And so I came away with the clear picture in my mind that the immunotherapy with IL-2, particularly in patients that were immunodeficient, worked, which meant that you could use IL-2 as an immunotherapeutic. And of course, we had already been through the experiments with Jerry Ritz and Mike Caligiuri and the bone marrow transplant recipients. And we knew that we could, which allowed us to identify a non-toxic dose of IL-2. And Zan and Giller were using a very low dose of IL-2, and we didn't have any side effects whatsoever in these patients. And so I'm thinking to myself, you know, this is what we need to do. We need to use IL-2 in the clinic. After the experiments were over and so forth, we all split up and made our way back to the States. And so on the long flight back from the States, I said to myself, well, you know, okay, we could use IL-2 in the clinic, but what do we use it in? Rosenberg has already given this high dose IL-2 to the cancer patients and basically give them all this toxicity and not very much therapy. And Jerry and Caligiuri have been using it to hopefully boost up the immune systems of the transplant patients. And so when I got back to Dartmouth, I said to myself, well, you know, the disease that really needs help nowadays, and this is in the late 80s, is AIDS, acquired immunodeficiency syndrome. Not only that, the cell that is deficient in the AIDS patients is the CD4 positive T cell. That's the cell that the virus infects. And then they gradually and progressively decrease over time. So you become CD4 cell deficient. And CD4 cells are the primary cell that make IL-2. So it was a no-brainer, really. This is what we should do. We should study AIDS patients. Now, the problem the other thing is that Gilla and Zan was already studying leprosy all over the world. They'd been to Brazil and to the Philippines and all these other places. And then I thought to myself, well, you know, I can't study that disease because they're already studying it on the one hand, and it's a heck of a way to do clinical research on a longer term basis. Whereas here we got all these patients in the United States of America that are immunodeficient and need boosting of their immune systems. I went to the dean at Dartmouth and I explained to him what I was thinking about and so forth. And he looked at me and he said, "No, we don't want any AIDS patients up here, not in the Northeast Kingdom." He said, "That's a big city disease. You know, homosexuals and drug abusers get AIDS. I don't want them in our hospital." So what could I say to that? I went back to the lab, and that basically sealed the deal as far as I was concerned. Then I made the decision to take Zan up on his offer to come to his lab on sabbatical, which I went around 1990, I think. And while I was there, I worked with Gilla on thalidomide, which is a drug that got a very bad name in the 50s because when it was given to pregnant women, it caused birth defects. But it was very effective in decreasing an inflammatory, marked acute inflammatory syndromes in the skin of leprosy patients. And nobody knew what the mechanism was. So we did a series of experiments and published them. And actually, it's been one of the most cited papers, my most cited papers, because the people interested in thalidomide and leprosy and so forth keep citing it all the time. But while I was there in New York on sabbatical, I was approached by the chairman of medicine at Cornell Medical School, which was right across the street from the Rockefeller University, to see if I might be interested in coming there as the head of the division of allergy and immunology. And I said to him, well, that's an interesting opportunity, but I said, I'm not an allergist. And furthermore, allergy is just a very small part of immunology. But in the clinic and so forth, allergy and autoimmunity. Autoimmunity was really taken care of by the rheumatologists, whereas then you had allergists taking care of allergy patients. And the rest of immunology was basically forgotten. It was not a clinical discipline. We chatted for quite some time, over several times and so forth. And I sort of thought that this is a critical time to develop a new medical subspecialty called medical immunology, as compared to medical oncology, which is the discipline that grew up to take care of cancer patients using chemotherapy in the 50s and the 60s. At that point in time, I had a new vista in front of me, and that was, we're going to move to New York and we're going to get back in the clinic. If you recall, I started out in hematology doing clinical trials on patients with cancer. So clinical trials was second nature to me. And I'm thinking to myself, so now we put our stethoscopes back in our pockets and we put on our white coats and we become doctors again. And so that was the end of this episode, and I'm going to stop there. Thank you. So if you've enjoyed this video, please like, subscribe, and sign up for my newsletter, where I'm serializing my new book, which is called The Quest for New Knowledge. You'll find a sign-up link below. Hey, thanks again. It's been great.